the final section in Chapter 1, Section 1.9, inverse functions. So what we're going to be doing is we're going to be taking certain functions that have certain properties about them and then creating an inverse, essentially something that undoes that function. So when you think about inverse operations, okay, what undoes addition, subtraction? What undoes multiplication, division? What undoes a square root, squaring? Okay, you have inverse operations, those undo each other. There's also inverse functions. And a function rule can be complicated. The more complicated a function rule is, the more complicated the inverse function rule is. But the whole idea is that it'll take a function rule and it'll systematically undo everything in the correct order that function rule did to your original x value. So it's important, for this to work, a function needs to pass the horizontal line test. We have the vertical line test for functions. The horizontal line test says whether a function has an inverse. So if you draw a parabola, and then you do the horizontal line test. Well, horizontal line test, all right, goes right through it twice. So a parabola does not have an inverse, and here's why. Inverse functions are reflected from the original. The original gets reflected over the identity, y equals x. So now let's take this and reflect it over that line y equals x. So here's our original f. Here's our, not prime, here's our inverse f to the -1. Now look at the inverse we got. Okay, draw a vertical line through that. The inverse fails the vertical line test. So the inverse is not a function. So in order for an inverse function to exist, the original has to pass both the vertical line test, has to be a function, and the horizontal line test. That means the function is called one-to-one. Each input has one and only one output. There are no repeated outputs. So the horizontal line test tells you whether that inverse function exists, because when you reflect it, that horizontal line becomes a vertical line. The vertical line test tells you whether it's a function or not. Now, the nice thing is every function I give you will have an inverse, okay? So there's 4 steps for creating or finding an inverse function. Use the horizontal line test to determine whether that inverse function even exists. Well, you can skip step 1. Step 2, what we're going to do is we're going to replace the f of x, the function notation, with the y, okay, that variable. And then what we're going to do is we're going to take x and y, we're going to flip them. All right? That's the first step to undoing a function. You take the inputs and outputs and you reverse their roles. And then you solve for that y value. So what happens is you're really going to take x and y, flip them around, and then solve for y. What that does is that'll undo everything that was previously being done to x. So, for example, let's show you right here. So we have y equals 5 minus 3x over 2. Now let's go ahead and interchange the roles of y and x. So that means flip them around. So now it's x equals 5 minus 3y all over 2. Now we want to solve for y. Well, in order to get this y by itself, we have to undo everything that's being done to it. The inverse is supposed to undo the function. So we're literally going to unravel this function, take it apart. Multiply that 2 over. Subtract the 5. And also divide by the -3. And that gives us our inverse function. And take a look at what we got here. In the original function, kind of go through the order. What happens in order to x? Take a minute to think about that. What's the story of x? Right, the story in order. X was going about its day. Everything was peachy. Then it got multiplied by -3. Then it got 5 added to it. And then it got divided by 2. And now X is all jacked up. So multiplied by -3. 5 got added. Divided by 2. Now let's reverse all of that. The last thing that happened was it got divided by 2. Now look at your inverse. The first thing to happen gets multiplied by 2. So the last thing was it got divided. First thing it gets multiplied. In the middle, 5 got added. Now in the middle, 5 is being subtracted. And the very first thing to happen to x, it got multiplied by -3. In the inverse, the very last thing is it gets divided by -3. So you see the opposite happening in the reverse order. Inverse function completely dismantles the original. Now that's finding an inverse. To prove that what we're doing actually works, we're going to verify. Okay? Now it's very, very important you understand the difference in that language. Finding an inverse versus verifying an inverse. Verify means to prove. It means to show beyond a doubt that what you have works. So let's real quick, let's take f of x and let's get its inverse. So x equals 5y minus 8, switching those around, x plus 8 divided by 5 equals the inverse. Let's do kind of a tertiary check here. X got multiplied by 5, then 8 got subtracted. Now we're adding 8 and then divided by 5. So we have that reverse order of the inverse operations. So now to verify, these really should dismantle each other and take everything away. So this is our verify step. We're going to create two composites. We're going to take the inverse and plug it into the original. We're going to take the original, and we're going to plug it into the inverse. So taking your inverse, x plus 8 over 5, plugging it into the original function. So 5, x plus 8 over 5, minus 8. So the inverse plugged into the original. Let's go the other way with it. Take the original, 5x minus 8, plug it into the inverse. So hopefully you see here, all right, in the original function, the x value got replaced with the inverse. In the inverse, the x value got replaced with the original. Now, some really cool stuff should happen. This is why I like composite functions so much. The most satisfying move in mathematics, the cancel out ninja swipe. Okay? You got 5 being multiplied, you got 5 being divided. Ooh. Now look what you have left. You have plus 8 minus 8. Ooh. Which leaves you with just x. Everything got completely dismantled and undone. We're right back to where we started, x. Over here we have minus 8 and plus 8. We have 5x over 5. And you're left with just x. Which, if you remember back to the beginning of this video, the original function, when you create the inverse, it gets reflected over the line y equals x. So, algebraically verifying, you create the inverse, and then you do both of those compositions to show that everything truly does get canceled out and you're left with x.